to the webinar covering the Model-Based Definition Accelerator from Inceptra. My name is Bill Grotzek. I'm the Director of Technology Solutions. What I have planned for today is to cover a little bit about our background, the inspection process, what we mean by model-based definition, and then actually get into a demonstration of our tool. Specifically, today we're very excited to bring you the model-based definition update, that is 4.0, and the enhancements that we've done along with that in some of our partners like Verisurf and NetInspect. So very quickly, a background on Inceptra. I myself have been here over 20 years. We have a lot of senior people that are in the Inceptra tenure, and we have over 25 years of experience in the CAD/CAM and PLM solutions. Approximately 15 locations across North America. Through 2016, we're the largest partner in North America for Dassault, and in 2015, we are actually the largest partner in the world. The reason that I mention that is that we offer a wide range of support options or services that are available to our customers, from implementation, training, and support. And these often work in tandem to understand our customer needs and really make the software work for our customers. And the reason that I bring that up is that that gives us the ability to understand the support calls that we're getting, understand what our users are experiencing when we get in and do training, and also some of the challenge areas that they have when we go through implementation. And that has really given rise to how we can help, especially in the inspection process. So we'll cover that very quickly. And really, this is just a brief overview of what we feel we're seeing out in the marketplace, that we have OEMs, and we also put propulsion in that group, specifically towards aerospace, that really have the responsibility of controlling the overall components that come together to make the final product. And so when they have control over the entire assembly, they want their suppliers to create parts and to certain specifications. The tier 1, 2, and down, all the way to the raw material supplier, have the responsibility of understanding those requirements and meeting them and producing quality parts for the OEM or for their customer. So in order to facilitate that type of communication that goes back and forth about the specifications and the demands of the part, we put in certain standards that go along in this environment. So we have aerospace standards such as an AS9102 for first article inspections, or the production part approval process for the automotive industry. So they both kind of speak the same language, and really it is that the OEMs, and propulsion is in there, communicate the requirements down to the supply chain. The supply chain consumes that information and then has the responsibility of producing quality parts. And the other interesting fact is at the run rate specified. So if we had, the reason that I add that critical component is that if we had all the time in the world, we could absolutely make a quality part every single time. It's making it at the production rate that's also specified. So there's a time component that's associated to that. So how is this information recorded? A lot of times we have inspection plans. So if you're making a lot of 1,000 components, maybe you have to pull off every 5th one or 10th one or 20th one and go through a sub-inspection process on that particular run. Or in proving that you can meet the quality demands that have been specified, often you have to do a first article inspection report. Also, we have to have the process documented. So what are we actually quantifying or verifying that we've produced a quality part on? Are we using ferrule arms? Are we using a roller arm? Are we actually using CMMs as a caliper? Is the equipment certified? Is the personnel certified to actually do those particular tasks? And then where is this critical information dictated to us? And typically that's in the model-based definition area. So model-based definition is our next topic, and it's just an insight into what we mean by that. So we used to be receiving the information on 2D drawings. So title block areas, notes on the drawings, the dimension callouts, the geometric tolerancing and dimension callouts that we have, specified manufacturing processes, all of that used to be dictated on the 2D documentation, and now we're seeing the trend that that's actually been moved up into the model. So everything is trending towards living directly in the model, and that means that we're working in 3D, but we still have items that we need to dictate or to capture that are notes-based or 2D-based. And so often we see that going in the specification tree. We see detailing information in the 3D as well. So dimensions, geometric tolerancing, the datums that we have, and then also process specifications are also included either in an actual note, excuse me, on the 3D or in the specification tree itself. So that presents some benefits and challenges just of the model-based definition approach, and that is, you know, one model will contain all the information that you need for design, manufacturing, and inspection. It eliminates the need for a 2D documentation, and it incorporates a wider span of people, not just designers and engineers. The challenge with that approach is that, of course, we still need some 2D documentation. So there's MOT sheets or manufacturing documents that specify how we need to make the part, as well as first article inspection reports are basically 2D based. So to go from that 3D to that 2D, it's a manual process, and it's not really creating new information, it's just filtering from 3D down to 2D, and therefore it's not very much of a value add in most of our customers. They would like to have that information automatically extracted from the 3D. Further, this is time consuming and prone to human error. So if you're doing this day after day, you're ballooning, you're extracting information from the 3D, copy and paste and put it into a report, or if you have to type something in, a lot of times that's prone to mistakes. So further to challenge this process of model-based definition, from the OEM perspective, it's very hard for them to be 100% compliant with the standards that are there. So just like in 2D, when you create a drawing and you don't have witness lines go over the drawing, or you don't dimension a particular feature in multiple views, we have the same type of standards that exist inside of 3D. And it's very hard for them to often have strict adherence to those standards. If we take a look at the example on the right-hand side, there's probably about 90 different callouts and characteristics that are on that model. In the strict adherence to standards, we have to make sure that each one of those are only displayed in one capture as we go through and basically create those captures for the supplier to disseminate that information or to consume that information. This is a lot of information to manage, and further, the OEMs often don't have visualization into what that first article inspection is actually going to look like. What did they actually dictate to the supply chain as the critical items that need to create that component? So they don't have a foresight into that. A lot of times they just send out the model. And almost universally from the supplier challenge aspect, we almost hear this all the time, that there is some type of missing information. So there is something incomplete on the model that they need to go back to their customer or to the OEM and find out exactly what to clarify some point that's on the model. And each supplier really kind of goes through this in their own defined process. So there's nothing that dictates how we get from the 3D to the 2D. Some do screen capture, some double click on the notes and copy and paste and put it into their own report. Everybody kind of has their own method of going through that process of getting it down to the 2D. And it's the other part of this is that you're trying to earn business from the OEM or from your customer, And that's difficult in communicating that challenge that you're having with the model. You want to show that you are confident in your abilities to make that quality part, and therefore you don't want to question too much the information that you've received and simply say, yes, I'm ready, willing, and able to make this component to the quality that's been specified. We've already talked about the time-consuming portion of that, and that this is kind of prone to human error. And the reality is, the final comment there is that programs are in different states of MBD completeness. So sometimes you'll get just the model and the notes, the specifications are in a PDF file. They're separate from the 3D. We've run into circumstances like that. So not every program is completely embedded in the 3D model. So we've got some challenges that exist there. Okay, so this digital continuity inspection really refers to the fact that when we start with the CATIA model with this information, this model-based definition information in it, we can run it through our process and extract out that information and accelerate this overall process. So there's different aspects and components to this that we'll highlight and get into deeper as we go through the presentation, but the red area here is something that's called Q-Checker, and what that does is it allows us to run predefined checks on the model to make sure that it's actually adhering to standards. Some things we can actually fix, and some things we can just get warnings or indications where there may be potential issues with the model. So that's an optional phase, but it does scrub the data and let us know where we may have some of our challenge points before we get to the next phase, which is the Inceptra tool. So this is the model-based definition accelerator. It creates a first article inspection report by extracting the information from the CATIA model and producing several deliverables. So one of those deliverables, now into the purple section, is the AS9102 in an Excel format. The other thing that we produce simultaneously is an XML file, and then we also create a ballooned CATIA model. So these are our downstream deliverables. The next slide simply just took out the Q-Checker portion and kind of elaborated on the green area, which is also some other opportunities that we have for where we can populate this data. So if we start with the CATIA model and we use the Inceptra model-based definition accelerator, we can still produce the Excel format, we still produce the XML file, and we still produce the balloon CATIA model. But now we can actually populate that to some downstream applications such as NetInspect. So we can populate the AS9102 at the same time to NetInspect, and then we can also use this XML file and the balloon CATIA model to feed in our measurement system, and our current partner is VeriSurf. So what this means is that a dimension that came from the CATIA model will have a characteristic ID that will be identical in the AS9102 Excel format, it will be identical in NetInspect, and it will be identical inside of VeriSurf. And that is exactly what we mean by the digital continuity as we go through this process. We're always using the same processes or the same reference as we go through this. All right, so let me continue on, and we'll elaborate on a couple of these applications that we've been using. So we talked about Q-Checker. There's about 350 different out-of-the-box checks that you can use with Q-Checker. About 30 of them pertain to specifics with functional tolerancing and annotation. The couple that have been bolded here are the ones that I'll turn on and actually demonstrate, and ones that we feel are most impactful in this process, and just semantic and non-semantic tolerancing, the occurrence of FTA types and captures. So, you know, how many times was that dimension shown in multiple captures, just so that you're aware of that. So we'll run a model through Q-Checker and get you a feel for what that process looks like. The next step is to actually run this through the data through the Inceptra model-based definition accelerator. And this is our application that's you can run on both parts and assemblies. It's configurable for different annotation methods. So if you have multiple customers that you're working for, perhaps you're working for Bombardier or perhaps you're working for Boeing, eventually, depending on where you're at in the supply chain, they may use different approaches. And so we have a configuration file that we can use or utilize behind the scenes to specifically extract out their type of formatting that they've done for their models. We also can configure the reports. We extract both captures and notes. The notes are stored in any location within the model, so it can be on an actual capture or it can be from the specification tree. We do automatic ballooning for the first article inspection, and we create that first article inspection report. And the very last line here, the XML file can be created and consumed or used to publish into NetInspect, Verisurf, as well as Delmia. So what this provides is a key extraction and population. So it's a consistent approach across all of our customer base to extract out this information and then populate it into the first article inspection report. There's no need for multiple attempts from each supplier, and we actually do error trapping behind the scenes. So if a dimension is actually shown in multiple captures, we're only going to balloon it once. Probably one of the worst things that we could do is if we took a dimension and we put it in multiple places on the inspection report, and then you inspected it and came up with a different measurement for whatever reason, you would have the same dimension, one potentially passing and one potentially failing. So we put that into the first article inspection report only once. All right, and we've talked about different configurations that are available for your different customer base. NetInspect is a partner of ours that has also become popular with the supply chain lately. There's over 6,500 companies. That's actually over north of 7,000 now. There's 52,000 customers, and I just haven't updated these, but at the time of creation, it's 1.4 million first article inspection reports that they have. There's already 1 million parts up there. So this is a tremendous amount of data. So what that means is that they can do data mining from the supply chain that has a great impact to the OEMs, and this is why they're using that tool. So much in that regard that even some of the new programs, if you want to be a supplier on that new program, you actually have to report your findings into NetInspect. So that is true on the 787, that any new part that comes out now has to be required to go to NetInspect, and they're working on that for the 777X. So Boeing, Honeywell, Spirit, Pratt & Whitney, the typical customers or OEMs that we're seeing are using NetInspect as their recording tool from the supply chain. And Verisurf is a inspection software application. The unique thing about Verisurf is that it can bring in the ballooned model directly from CATIA, and it keeps the balloons associated to the actual dimensions. So along with the XML file, along with the balloon model that we provide, you can now actually create your inspection plan inside of Verisurf. And Verisurf also has the flexibility of running multiple types of equipment. So there's various different CMM equipment that they use, as well as different roller arms that they can take input from, as well as, if you're interested, they can actually provide the inspection equipment themselves. So this supports the fact that the digital continuity thread is maintained. We can bring in the model. It can bring in the dimensions that are ballooned. We know which dimension corresponds to what balloon. We inspect it, as well as we can write this information or the inspection results out back to the XML file, which we're going to bring into the Inceptra Model-Based Definition Accelerator. We're going to verify it, and then we can actually populate the results back up to NetInspect if that is where you'd like that to go. So getting to the point of the webinar today, that was just background information. We do have MBDA 4.0. This is our enhancement list. So in the first article inspection report, we've actually touched Form 1, 2, and 3. So on Form 1, there was a request for doing partials. So in the past, we've run through the entire model, and basically it was an automated or accelerated process to basically extract everything out. We've enabled a partial mode. So if this is a dimension that's changed, if it's a tolerance that's changed, and you only need a partial, you now have the ability to do so. In the Form 2, there's been a request to extract out part notes and basically parse it against known keywords. So oftentimes we'll see per ASME standards, for example. That would be an indication for us that that should actually be parsed or put on Form 2. And Form 3, we've added conditional formatting. The other two highlights here is that when we publish to NetInspect, we're actually also uploading attached files. So what that means is we are producing the 3D XML of the balloon model, as well as a JPEG of each one of the views. We'll show that off. And then we're also, for VeriSurf, having the ability to create this XML file along with the balloon model, send that off to VeriSurf, they do the inspection, and then we get the results back. We can color code the results and actually publish those results to NetInspect. So here's kind of that was an overview. Here's a little bit more in detail of each one of those areas. There is the partial FAI mode that's available in Model-Based Definition Accelerator now. On Form 2, we have the option to specify the specifications that we'd like to parse and put on our first article inspection report for Form 2. The report that we create on Form 3 actually has conditional formatting. So this will let you know when you're within tolerance, when you're marginal, and when you're out of tolerance on the measurements that we've provided. When we, for NetInspect, the automatic publication now shows up on Form 1, where we can show the different JPEGs of the views that correspond to Form 3, as well as we put up the 3D XML to NetInspect. So this you can view in a free 3D XML player on any desktop. So it's a free player that allows you to download this 3D XML, and then all of the views that we've ballooned actually come over. So we'll demonstrate that as well. And finally, before we get to the actual demonstration, the VeriSurf import of their results will verify that this matches the input that we've exported out to VeriSurf, so that no one's actually tampered with any of the data and didn't loosen up any tolerances or anything like that. We do a checksum on the data, and then we can actually color code the dimensions to let you know which ones are out of spec and which ones are in. So you get a visual result inside of CATIA, as well as in the end we can populate those results to NetInspect. So our the arrows here are, let me explain, the first pass through are the larger, thicker arrows. We take the CATIA model, we run it through Inceptra's Model-Based Definition Accelerator. We produce an Excel format, an XML file, and a balloon model. We publish those results to NetInspect, so now there's a first article inspection report waiting at NetInspect. If you so choose, you can also employ the VeriSurf, where we'll send the XML model and the balloon model to VeriSurf. They will consume that information, create the inspection, and give us the results. We bring that back into Model-Based Definition Accelerator, where we can color code the results directly inside of CATIA, as well as publish those results to NetInspect. So the second round here are the thinner arrows and kind of that workflow. All right, so with that, let me get into the demonstration and give a brief overview of some of the things that we've been talking about. So as we take a look at the part, I'm now in CATIA. We've received a part that we need to manufacture. One of the items that we talked about is the adherence to standards. We're checking the model before we ever start on this process. Garbage in equals garbage out, so let's take a look at the model and run it through QChecker. QChecker is a commercial application that's available. They have different profiles. We've configured one that specifically checks functional tolerancing and annotation items. And what that means is as I run that check, it starts to give me feedback upon all of the checks that we've enabled and whether they've passed, whether they're marginal, or whether they're a critical item. So one of the things that you'll often see is that first off, we have an annotation set on the model and it's not even turned on. So if you're using a third-party viewer, where this is critical is the fact that the third-party viewer doesn't know how to turn on the annotation set and will not even realize that there's any notation on the model whatsoever. Our application actually automatically turns this on, but it's just a good demonstration of capability. So in some cases, we have the ability to heal that. So as soon as I select on it, now we've actually corrected that critical problem. We've actually turned on the annotation set through QChecker. We've got some other items that now we realize in the capture environment that the capture is actually active. And what that means is that if we go through a ballooning process, any new balloons that we add and there's an active capture, every time we go to display that capture, it's going to show or display those balloons. So what you might want to do is actually deactivate that capture, and we've solved that particular item. A couple other items, occurrences of FTA types and captures. And what that means is that what has happened is that a particular dimension is actually being shown in multiple captures. So it's in the top view, section view, datums, and section view B. So this is against the standards. So if I take a look at the captures, you can see that it's actually in 4 of approximately 9 or 10 of these captures. We're supposed to display the dimension only in one capture, and that's kind of like on a 2D document, you display the dimension only in one view. So on this, you'll notice that there is no healing. We don't know which one you would like to show this for, so you're going to have to manually go through and determine which one that is, but it does give us a little bit of a warning on that. The last one to talk about is semantic and non-semantic tolerancing. It's realized that one of these tolerances is non-semantic, and really what that means is that there potentially is no issue with it, but there is no guarantee that this is adhering to standards. So it's just some note that somebody created on the model, and that means that it's non-semantic. And what that specifically can mean is that we've got a perpendicularity condition that's on here, and I can simply just go, what's opposite of perpendicularity? Parallel, and I could set that to it, and no bells, no whistles, no warnings went off, and that's because this is non-semantic. If this was a semantic tolerance, obviously we would know that this hole is actually perpendicular to datum reference A, and that is the criteria that it would only allow us to put on there. So just again, some warnings that if you run into non-semantic tolerancing, it may not actually be formatted correctly, or it may actually be gibberish that got put on the model by mistake. Okay, so let's start going through a model and processing it. Now we've scrubbed it, we've got our issues fixed up, we've put the dimensions on the right captures, we've got a clean model, and we're going to process that now. So with model-based definition accelerator, what you'll notice is that we have this is 4.0, so let me start in that area, that this is version 4. And we've got a couple options that run in the background. So you can configure these different options to match the supplier that you're receiving data from. It highlights what we're going to annotate. When we run into non-semantics, do we actually want to put an X on there? Do we want to balloon datums, etc.? Are we working in inches or millimeters? And then it's really just kind of dictating what the pick and place process looks like. So on on capture sheet number 1 in cell number C4 that we're going to populate into this template that we provide, we're going to put the value of the part number from this model into C4. So it starts to dictate what we're extracting and where we're actually putting it. What you will notice is that in 4.0 we now have a specification file that's here, and this specification file contains the keywords that may exist in the model that we want to put on form 2. Further on here, because we are going to net inspect in the end, we have the criteria for our user login that we're going to use for net inspect also recorded. So we have we've configured the options that we'd like Model-Based Definition Accelerator to use. The configuration file is denoted here. The model that we're going to run it on is the same model that's active in the CATIA session. We've got a couple different modes that we can actually enable. So we can simply just create 2D views. Sometimes people just want to extract out the information from the model and create an Excel file, maybe for quoting. You can certainly do that 2D view. Or we can go one step further where we create the 2D information into the template that we've specified and balloon it. So I'll also tick mark that I want to publish this to NetInspect, and I'd also like to create the XML file for Verisurf. The captures that are now next in the list are actually the captures that correspond directly to the model. So we have those listed. I can right-click and select all. I can deselect individual ones. So release is just a blank view. You can include it or not include it. It would be fine. If there's nothing to balloon, I tend to leave that off. And then we'll start the process of the actual ballooning. So out of the captures that I've specified, it's going to display each capture. It's going to turn the background white, all the dimensions to black. It's going to balloon all the key items that we've indicated through the configuration file. So you notice that the dimensions on here are actually ballooned, but the datums are not, for example. We have the option to clean this up, so we get kind of a cleaner view. We take our best estimate that we balloon to the lower left of the annotation that we find. So you notice that most of the balloons are to the lower left of each of the components that we found. And then we also start and basically renumber the balloons so that we go into a clockwise fashion for ease of reading. When I go to next capture, it's also going to verify, because people use varying different environment variables and various different configuration files, the level of detail that we have in here may actually change, so to what precision is actually displayed. So I can set the precision inside of here, and then if I look around the model, I can see that they're all to the third decimal place. So I'm going to say, don't go and ask me about each one. We're going to keep it all the same for this particular capture. So we continue through this cycle. The next round of captures, you'll notice that there's 3 150 dimensions. Now we're going to keep that identifier 24, 25, 26 in all the references of every instance that receives this data. Our first article inspection report, NetInspect, as well as Verisurf is going to have a unique identifier even for the same dimension. So there will never be any misunderstanding about which dimension is according to which key characteristic. Continuing on this process, again, it's going to ask us about the dimensions. They're all to the third place. So we continue through that. And what I usually ask our customers is, think about going through 80 of these or so dimensions and recording all of them so that they look appropriate in putting them into a report. How long would that take as a comparison? The other thing to point out is that 64 and 68 are actually referring to flag notes. So we'll show you how that is treated inside of the report. A couple more captures in here. I believe this is the last one. So we did about 82 balloons. We captured 82 unique items. Watch my Excel icon over here on the right-hand side. So we're going through the process right now of actually gathering all that information, creating the Excel report, and at the same time, we are connecting live to the NetInspect site and publishing that information. For time's sake, let me go ahead and take a look at the report that we've generated. And this contains the typical items that we're looking for. So our Excel, you'll notice 2537 has been published successfully to the NetInspect site. So we'll go take a look at that in just a moment. So as we take a look at the Form 1, you'll notice that C4 contained the part number, which I pointed out earlier inside of our environment file. So this is just the result of the pick and place. So all that information that we've configured has been put into this report. If we had an assembly, this would be ticked off as assembly first article inspection, and we would fill out box or columns 15 through 18 with the bill of material information of all the elements that or components that are in the actual assembly. So if I go to Form 2, now you'll notice that there is a change. What we've done is we've identified any note that should be populated in Form 2 based off of our specification file. So specifically what that means is that if I take a look at part notes here, what that means is that there were 5 part notes, but only 4 of the 5 actually called out a specific specification. So per ASME, per PCS, per PCD, per PCS. So these are the ones, these 1, 3, 4, and 5 that actually have been recognized by our specification file, and they get populated. Part note number 2 does not have any of that terminology, but it does talk about the flag note 2 that's on here, but it doesn't belong on Form 2. So you can choose to employ this or not. And then as we go further through the first article inspection report, we start getting to the Form 3 supporting items. So here's the ballooning capabilities. You'll notice that it denotes that this particular view contains 1 through 13, 14 through 28. And as we move through the particular views, we get all of them all the way up until the Form 3 formatting. So this dictates which reference location it came from, and I will continue on with going through these. So all of that's been captured, and then you'll notice the one thing that I wanted to point out is that on section view AA, and if I bring this back just a little bit, section view AA, that was the one with the flag note. And we take a look at, well, where did it actually get this value from, because it only populated just a balloon on that flag note. Well, that actually synchronized up to flag note number 1, and then we extracted this information and then correlated that to the flag note number 1 value that should be populated in our first article inspection report. So that's in on the inspection. Let's go take a look, because it did populate up to NetInspect. So I'm going to go to the actual live NetInspect site. If you're required to populate information up here, you would first log in. So everything that you do on the NetInspect site is required by username and login, so they know exactly who is in on the data. Let me see if I got that correctly. And then you'll have access to that. So if you ever populate anything in here, if you ever change anything, all of that information is tracked. So if I take a look at my first article inspection reports that are up here, we'll see that the last one, the 2537, is the last one that I just populated on this date. And that was the one that got indicated through our notification through the model-based definition accelerator. So this is identical to the first article inspection report that we have just taken a look at inside of Excel. You'll find all the characteristics match, all of the population of the information matches, as well as this is new for version 4, that we've actually populated the views that go along with this. So if I wanted to do the front view and see the actual balloons as I'm taking a look at this report, I certainly can reference that. The other item that we have is that we've populated the 3D XML up here. So I have the ability to save that off, and when I save it off, then I can actually use a free 3D XML player from Dassault to review this information. So what's in that information? Well, it's everything that we've populated so far. So if I go to the front view, you'll notice that all the balloons along with all the dimensions are there. Top view. So now you can look at this report, and you can also reference the 3D information at the same time. So if you're looking for a specific dimension, I think it was in the top view, you may remember that we had, well, which dimension is it for the 150? Well, the 24 is calling out this 150, the 25 is calling out the 150 that's in the middle. So there will never be any confusion for that further. Plus, you have the views to look at. Form 2 for here also contains our specifications, and what NetInspect does is it actually calls out which standard, whether it's ASME or PCS, and populates column 6. So they have their own internal linkage to what we've actually populated through here, and they maintain that. And then let me go to Form 3. And when we pull up Form 3, what you'll see is these are the exact dimensions that were called out onto Form 3. Now the interesting thing about what we've done when we populated to NetInspect is the fact that this information has had business logic formatted into it. So we've dissected this, we've created all the symbols, so whether it's a profile symbol or the actual tolerances that go along with that, and then we put the business logic down below. So when you type in your actual results, so let's say we did 3/8 on that, that's within tolerance. If we get marginal right on the boundary of the tolerance, it shows up as yellow. And if we go below the tolerance, it actually flags it as red. So this is the business logic that we've provided when we populated to NetInspect, and then they display these results in this way. So similarly, what we've done, which is also an enhancement on our particular results, if I go to that in our Form 3 on our Excel page, and maybe you're not using NetInspect, if I put in the value for those results, we actually get the same color coding that is supported by NetInspect. So if I'm marginal, it's going to show up as marginal, and if I'm out of range or out of tolerance, then it shows up as red. So we've got those color codings that go along with this. The last part that we're going to talk about is the Verisurf integration to this. So let me do a quick video presentation. So as we've created the first article inspection report, we've populated that to NetInspect. It's waiting with the first article inspection report up there. These two have direct continuity between them, as well as the information that we've sent over to Verisurf. So as I take a look at the Verisurf item, this is now that part inside of Verisurf. It has the dimension along with the callouts identified. So it brings in the geometry and also verifies the geometry, as well as all the captures, all the dimensions, all of the balloon characteristics that we've put in for each of these dimensions are captured. And what we can do from there is actually come up with the inspection plan. So for example, there is a specific profile call out on this part, which requires us to take about 28 measurements to let us know if we've actually satisfied that profile tolerance. We've also got a surface measurement for parallelism that we need to do 9 measurements on. So it's not a correspondence of one measurement per each characteristic. There may be a number of measurements that are required in order to satisfy whether or not we're in or out of tolerance on that particular condition. And what that actually looks like is you can kind of see that the targets are displayed. You saw that prior. Now we can take the roamer arm and actually identify those points and take the measurements of those points directly with reference to the model that we've provided to VeriSurf. So this is just a close-up view of what those measurements actually look like. So you put the roamer arm exactly in the target location and acquire that measurement. And what happens now is that VeriSurf will actually write out these results for us. So let's take a look at what that looks like. So while I'm in the model, let me go to something like the front view. Inside of our model-based definition accelerator, we can actually publish to NetInspect our VeriSurf results. So let me bring this over just to the side here. I'm going to publish to NetInspect the VeriSurf results. And so these are the results that we've just recorded, figuratively, of course. I don't have the roamer arm actually with me, but the process goes something like this. So the first thing that we do when we bring those results from VeriSurf back to the model-based definition accelerator is that we identify that the characters actually match. So the number of characters that we output are the same number that we're getting back from VeriSurf. The other item that we're doing is a checksum on here to make sure that nobody's tampered with a 10,000th dimension and turned it into 15,000th dimension because maybe one of the measurements was off and they want that to go through quality. So that is one item or one aspect out of this. The other thing that you'll notice is that we've actually color-coded the dimensional results for review on the model itself. So now you get a visual feedback on the model of which ones are out of tolerance and which ones have passed the quality conditions that have been specified in the first article. So I can display each of those captures, which ones are marginal, which ones have passed that criteria, and review this particular information. So when you're satisfied with that, you can actually publish this up. So you'll notice that this one is for first article inspection number 2473. So before I go and publish that up, let's go take a look at our inspection report here. And I am going to go to 2473, which is this one. And I'm going to go to Form 3. And so on Form 3, you'll notice that all the results here are actually blank. So what will happen is that we're going to take the actual results that we received from VeriSurf. I don't have to retype it. I simply need to publish this up, and we're taking the actual results that we had from VeriSurf, the actual measurements that we've validated that agree with what we've sent out, and now we're publishing those to NetInspect to this specific 2473 first article inspection report. So what happened here? Well, it just needs an update, so let me update this screen. And we'll take a look at the 2473, and you'll notice now that all the results have actually been written up to NetInspect, as well as color-coded through here. Okay, so we've kind of come full circle. not only from the demonstration perspective, but also full circle through this process that we've outlined here, taking a CATIA model, going through Model-Based Definition Accelerator, creating the inspection report in Excel format, the XML file, the balloon model, populating that to NetInspect, sending it out to VeriSurf, getting the actual results, verifying that the report we sent out is the exact same report that we brought in as far as characteristics are concerned, color coding the model, and then when we're satisfied, we can actually populate that information up to NetInspect. So thank you for your attention on that. I will turn this over to any kind of questions that we may have. If you have any questions, please record them in the chat session or the chat window. And I'll give that just a minute to come through. Jason, do we have any questions that I may not be seeing?
We did have one come through regarding QChecker. Is QChecker an add-on, or is that included with the Inceptra model-based accelerator? Okay.
A couple points of clarification. I do want to mention this as we go through. QChecker is a separate application. It is optional in our workflow that we showed. What it does is it obviously scrubs the data and lets you know where there are potential issues that might be encountered with running that model through Model-Based Definition Accelerator. The reason that we find it valuable is that it is kind of an independent, unbiased look at the data. So, hey, I ran this model through QChecker and then let me know that some of these things are out of standard. It's an easier way to disseminate that information to your potential customer. So, one, it is optional, and two, it is a separate application from Model-Based Definition Accelerator, and that's we want to make that distinction. So that's one point that I'd like to make on that. The other point is the 4.0 enhancements that we have. They are available as an update to anybody that is current on maintenance. It will require a new updated Model-Based Definition Accelerator license. So if you're up to date on your maintenance, you will be able to get that license, or it should go through our support staff. They would send that license to you. It does require, obviously, an update to the software as well. And the last thing to point out is that not all of our customers are going to NetInspect, and not all of our customers are using VeriSurf. We do understand that. And these are optional add-ons that go to the base Model-Based Definition Accelerator application. So they are add-ons that are available to you in the 4.0 release.